Please make sure to mute your microphones. Okay. I'm still waiting for the recording to start. Yes. Recording started. I'll start the lecture now. Please make sure that your microphones are muted. Okay, so this is the last lecture. Okay, so in the previous lecture we discussed a few things like the operators. And we said we have mainly the most important operators that we are going to use them a lot are the arithmetic operators, which are our operations, which are addition. We write it like x plus y, subtraction x minus y, multiplication x asterisk, not start asterisk, y, division x slash y, and be careful. There will be some kind of confusion between slash and backslash. Okay, slash is used for division and is used for what? For comments also. When you write comments, you use a slash. Okay, backslash is used for example, backslash n, backslash t, backslash control. Usually, I use it to control strings. Okay, you have to be aware of this. There's a big difference between backslash and the slash. Okay, remember this. So slash is used for division. Modulus or modulus, which is the we use the percentage sign, and to explain the meaning of modulus, I have prepared some example to you. We will execute it. We'll implement it. Actually, the modulus, for example, 7 mod 2 equals 7 over 2 is equal to 3 and 1 over 2. So the mod is this one. The result will be 1. Okay, the remainder, we call the remainder. Now example, this example we explained it last time. We found the sum of 3 integers. So I'll define integer x, integers x2, x3, then result, and result equal x1 plus x2 plus x3, and I printed the result. Okay. This also another example we discussed last lecture, which finds the value of addition, subtraction, multiplication, division, and the mod operation. Constant and literal. We discussed the constant and literal. We say the constant are we cannot call them variables because they are constant. Are values that cannot be changed during or throughout the execution. Cannot be changed. And as I told you, there were 2 methods or 2 ways to define them. Either to use this one. Here you don't need to use the type. You don't need it. Okay, just write define L as 10, define W as 5. That means L, wherever I use L, it will be substituted by 10. Wherever I use W, it will be substituted by 5. Define MSG message, a string. Okay, then you can use them directly. There's another way to, and remember, these come before the main function. Okay, this is very important to notice. The definition, the first one, the definition of constants should come before the main function. Now the other type, which does the same thing, or the other way, which does the same thing, is to define them in the main function using the keyword constant. Okay, constant integer L equal 10. Compare it with the previous one. We wrote only hash define L space 10. I don't think we have semicolon even. We don't have semicolon. Okay. So this is equivalent to this one. So to compare between them, here instead of using this one, I use constant. I need to define the type. Okay, then the name equals 10 and semicolon. So all these things were not used in just me highlight these things. See this one, the type, you need to use the type, the name is there, equal, we need to use it, and semicolon. Okay, all these things are not used in the definition. So this is, of course, we tried this also. Whenever you want to change the value of the constant, you will get an error. If you remember, we tried it and we got an error. And these were the questions that I've given to you to answer. We'll answer them later. Now, this is the first question. We answered the first question right. A program that reads two numbers and prints the sum of the two numbers. Here, if you can see, as I told you, wherever you find these words, the word read takes, the user enters. All this means you have to use cin, okay, to read the variables. That's why in the question here I have that reads. Okay, the word reads means I have to use cin. So cin, I read the first number cnx and the second one, and integer r equal x plus y, then the sum is r, and that's it. Okay, this is all what we discussed in the previous lecture. Now we'll continue with today's lecture and we'll take more examples. We'll continue with the operators. So, okay, this part 2. Now the difference, the first thing that we want to discuss, the difference between integer and real number division. If you can see this program, these programs are almost identical. This is the same as here. Using namespace, integer, integer. The comments also the same. But here I used integer and here I used double. I will say integer will take only the real or the integer part. There's no fraction. That means if it's 1.2, it will take 1. If it's 1.8, also it will take 1. Okay, so integer x equal 5, integer y equal 3, integer r equal x divided by 3 by y. Then the result is r returned. After executing this, I will get the result of 1. Now, if it's double, if you can see the same value, x is equal 5, y equal 3, and r double r equal x divided by y, then the result will be 1.1667, while here only 1. Why is that? Because here is integer, and in integer only we take the integer part, while here it's real, it takes the floating point as well. Is it clear? Do you have any questions? Okay. If you don't have any questions, then let's go to the mod operator, which is very important, and we explained it in the previous lecture. We'll explain it again here. First of all, you have to be aware this should be applied only to integers. You cannot perform mod operation or operator applied to double or to character or to other. The type should be integer only. Returns the remainder of the division. For example, this is an example. 5 divided by 3 equal 1 and 2 over 3, then the result will be 2. By the way, it's new to you, but it's very important. Okay, so this is an example. Integer x equal 5, integer y equal 3, r equal x mod y, then the result will be 2. y2, again, 5 divided by 3 equals 1 and 2/3. This is the result. Okay? Just to avoid having a boring lecture, I'll give you this question. Okay, find 13 if R equals 13 mod 5. C out R. What's the output of this? What will be the output? Come on. I'm waiting for your answers. Anybody? You can do it on paper. Find R equals 13 mod 5. C out R. What will be the output of this code? Nobody? Okay, I'll solve this one and I'll leave the other one to you. Now, if I divide 13 by 5, what's the nearest number close to 13, which is divisible by 5? Of course, 10. That means 10 divided by 5, that's equal to 3/5. And if you remember in the school, how do you usually change this? I mean, convert this to this format. So 5 times 2 plus 3, that means 13. Now the result will be 3. Okay. Now, what if R equals to 43 mod 7? What's the value of R here? This you have to answer it. I'm not gonna answer it, please. Should I select randomly?
The result is 4.
4?
3.
3.
No,
How is that?
Yeah.
Sir, I got 1.
45.
1 second, one by one. Now we are talking with Khulud.
Yes.
Okay, go ahead,
The
Khulud.
result is 3.
How is that?
45 divided by 7
divided by 7
equals
2.
2.
Yeah, how to? 45, is it divisible by 7?
No, still wait.
Okay. Who was speaking next?
Me, sir.
Yes. Who's this? Khulud, wait,
Omar.
let's see who's next. Omar?
Yeah.
Okay, Omar. Tell me, what's the answer?
I got one.
1?
Yeah.
How is that, Omar?
43 divided by 7.
All right. The nearest number to 43, which is divisible by 7, is what?
42.
42, right?
6.
Exactly.
Yeah.
7,
it's 6,
42
1
divided.
over.
Yes.
So it's 6,
1
1 over 7.
7, exactly.
There's 1.
So 1, very good. All right. By the way, if it's the largest very number, for example, if very large, if the number is very large, let's say if I want to ask you 1, 2, 4, 7 mod 43, how to do this? This will be sort of difficult, right? So I'll tell you the way how to do it. First of all, let's start calculator. Okay, divide the number by now 1, 2, 4, 7 divided by 43 equals. It happens that it's divisible. Let's change it to 45. Okay, so I'll go back to divided by 45. How to delete this? Okay, I'll do it again. 1, 2, 4, 7. 1, 2, 4, 7 divided by 45 equals. See, now this is the result. I'll delete or I'll subtract 27. Okay, then this I will write it here also. Minus 27. Okay, equals this one and multiplied by 45. I'll explain to you. Now this is 32. The result is here. The result is 32. I think I need another slide. I'll do the calculations here again. All right. So let's take the same example. 1, 2, 4, 7. 1, 2, 4, 7 mod 45. First of all, divide 1, 2, 4, 7 over 45. Not integer, I mean as real numbers. So the result will be I'll go back to the numbers. I'm sorry, I just cannot remember the numbers. Okay, so here the numbers are 1, 2, 4, 7 divided by 45 equals 27.7111, etc. So this will be 27.7111, etc. So next we said we want this, we remove this part. How to remove this part? In the same calculator, while you are still having the result, minus 27, okay, you will get 0.71111, etc. Okay, so now this is all right. Now multiply this by, I'll take 0.71111 multiplied by 45. This will give you, let's see what will be the result. See now, I'll subtract 27, it's easy, equals, multiplied by 45, this equals 32. So the result will be 32. This is if the number is very large. The same thing if I want to do it like With small numbers, also the same thing. If I say 13 or 14 mod 4, okay? Do the same calculations. 14 divided by 4 equals minus what? Minus 3 equals times 4, that means 2, okay? 14 divided by 4 equal 14 by 4, which is equal 3.5, right? Then minus 3, I will get 0.5 times 4 equals 2. So this is the result. Okay, it's easy if you follow this procedure for any number, you can find it easily. Okay, so this is the mod operation. Do you have any questions regarding the mod operation? And by the way, when we finish the lecture with the scratch, with this writing, I will share it with you. Okay, very well. So we finished the important arithmetic operations. Still, we have more operations to study, but here we need to focus on something. If I ask you now, I'm sure everybody will answer the correct answer. If I ask you x is equal to any numbers, 2 1 second, times 3 plus 5, what will be the result? If you don't want to answer by voice, just type it in the chat box.
11.
11. So we got the first answer is 11. Any other answers?
16.
16. All right. There are two options, either 11 or 16. But which one is correct? Now, this will be correct in both cases if we don't have rules or regulations. But here we have rules and regulations, which shows that the execution should start with the operation between the parentheses. So I'll start with the parentheses first. Then I apply the multiplication, the division, and modulus, then addition. So here, although by the way, intentionally I left this space, okay, but the execution will be first 2 times 3, which is 6 plus 5. Why? Because I execute the multiplication first. This equals to 11. So 11 is correct and not 16. Let's see another example. This one. If r is equal 5 plus 2 times 4 times 3 plus 1. So the execution will be first I will start with the numbers between the parentheses. In this case, this equals 7. Then multiplication, 7 times 4 times 3. In this case, 7 times 4 times 3 equal 48. Okay, this is 7. This is 48. Then I'll add the last one plus 1 equal 49. Okay, sorry, 84. Okay, then this will be 85. Okay, so remember that first the parentheses, second multiplication, division, and mod operation, and finally plus and minus. So this 1, 2, 3. Getting back to our previous example, this will be 16 when if 3 times 3 plus 5, sorry, 2. Okay, in this case, 2 times 3 plus 5, 8. This equal 16. It will be correct, but you have to add the parentheses. Okay. The sequence is, as I told you, first between the parentheses, second the multiplication, division, and mod operation, then plus and minus. Do you have any questions about the arithmetic operations? Please take 1 minute to think about it, read it, and see if you have any questions. Here are the mathematical, the mod operation, etc. Now, the other part or the other kind of operations is the bitwise logical operations. What is the bitwise logical operations? If you remember, in discrete mathematics, if you study it or not, or in digital logic, if you study it, I don't know. But in general, we have the bitwise. Any number can be represented by a set of zeros and ones. Like if we are talking about binary, number 3. Number 3 is converted to binary to be 0, 1, 1. Okay? Why 0, 1, 1? Because according to the binary conversion, this will be 2 to the power 0, 2 to the power 1, 2 squared, 2 to the power 3, and we'll continue, of course. That means there are weights 1, 2, 4, 8, 16, 36, 64, etc. So any number, if I want to remember to represent any number, let's say I want to represent the number 7. 7 can be obtained by 4 plus 2 plus 1. So 1, 1, 1, and the rest are zeros. Okay. If I want to represent, I think I have a space here. Here, space. Okay. Just to remind you, I'm sure you study this, but again, 1, 2, 4, 8. After 8, we say 16. Then 32, 64, and so on. So let's try to represent numbers. I'll start as we started with 7. 7 can be obtained by 1, 1, 1, 0, 0, 0, 0. Okay. Usually we use only 4 bits. I'll tell you why. So if I want to remember to represent, give me any number from 0 to 9, 5. Okay, 5 can be represented by 4, adding 4 and 1. So this is 5. Okay, if I want to represent 12, for example, this is represented in a different way. I will consider this as they call it the 8 bits are 1 byte. So I repeat the same one: 1, 2, 4, and 8. 1, 2, I will represent 2 here, and can be obtained from 0, 0, 1, 0, and 1 can be obtained from 1, 0, 0, 0. So the number is 0, 0, 0, 1, 0, 0, 1, 0. Any other number? 46. I'll take 6 here. 6 can be represented as this one. Why? Because 4 plus 2. And 4 can be represented as 0, 0, 1, 0. So this is the binary representation of any number. Okay. Now in bitwise, let's get back to bitwise. Bitwise will perform the operation the AND, the OR, exclusive OR, right shift, left shift on the binary operations. So let's start, for example, The and, I can use this ampersand. Okay. The or, only one or. This is the exclusive or. This shift bitwise right shift and this bitwise left shift. And operator that applies to the binary representation of the numbers, and these are the operators. Let's take this example. Integer x equals 5. Integer y equals 3. Integer r equal x and, okay, and y. The result is 1. Why is that? First, let's represent x with 5 in binary. So as I told you, 1, 2, 4, 8, etc. Okay, repeat it again here. So 5 means I can get it from 4 plus 1. This is 5. So it's represented as 0, 0, 0, 0, 0, 1, 0, 1. Okay. Y is a 3. How to represent a 3? Always write this 1, 2, 4, 8. So 3 can be represented like this. So 0, 0, 1, 1. Okay. R is the result of ANDing, bitwise ANDing of X and Y. I remember the AND here, the word AND means 0 and 0 gives me 0. 0 and 1 gives me 0. 1 and 0 gives me 0. Only 1 and 1 will give me 1. So in this case, I will do this. 1 and 1, for sure it's 1. 0 and 1, 0. 1 and 0, 0. 0, 0, there is a 0. So the result is this one, which equals to 1. Do you have any problem with this binary representation? Because you will study it, or if you didn't study it till now, you've already studied it in discrete mathematics and in digital logic design if you registered for. But for sure in discrete mathematics you'll study it. Here, just to keep it with you, A, B, and F. 0, 0, 0, 1, 1, 0, and 1, 1. Here F equals A and B. 0, 0 will give me 0. 0, 1 will give me 0. 1, 0 give me 0, and 1, 1 will give me 1 always. All right, so the only way or the only time that I get an output of 1 is when both are 1. And this, by the way, will be used in the control, and then when we use if statement and multiple conditions, you will see how useful is it. So let's see the OR. First, no, this is the AND. This is repeated. Okay, so 5 is represented as, again, whenever you get such kind of a question, put 1, 2, 4, 8. Okay, 5 is 0, 1. Okay, 0, 1, 0. 3 is 0, 0, 1, 1. The ANDing is 1 and 1, 1, 0, 0, 0. So this will be converted to be 1. Let's try the OR. Next one is OR. Remember that we represented 5 as what? 0, 1, 0, 1. And the 3 as 1, 1, 0, 0. The OR here is different than the AND. Why? Here I have A, B, and A or B. 0, 0, 0, 1, 1, 0, 1, 1. So 0 or 0 will give me 0. Wherever I find 1, the output will be 1. Okay? This is the OR operation. Don't worry, I'll share this with you. Okay? So let's do it here. 1 or 1, 1. 0 or 1, 1. 1 or 0, 1. 0 or 0, 0. So the result here will be, remember, 1, 2, 4, 8. So 4 plus 2 plus 1, which is equal to 7. Okay? Let's try the other here, exclusive OR. Or before continue, let's implement this and see if we are doing things right. Okay, I'll keep the comments also. This is the OR, this is the AND. So I'll just copy this code and go to the compiler, print it here, paste it here. All right. So if you can see here, we have integer x equal 5, y equal 3, integer r equal x, and remember this is only one and because I have another instruction which is two ands. Don't worry about it now. Let's focus on this. Now if I run it, I'll get 1. Okay, so this is the result. Let's change it to OR. I'll remove this. I'll change it to OR and execute it. If you can see, the result is 7. I think this is what we got here. Okay. Now, exclusive OR. Let's try exclusive OR. Run it. The result is 6. Why is that? Okay. Let me show you why the result is 6. See, exclusive OR timetable. I'm sorry, if you give me 1 second. الو اهلا استاذنا الله يسلمك شو اعتذر يا شباب. اوكي. فوصلنا اخر شيء هو I'm sorry. We were talking about the exclusive OR. So I think this is the last part and we'll continue next lecture. I'll share this with you also. So here what I have A, B, and A exclusive OR with B. So 0, 0, 0, 1, 1, 0, and 1, 1. Actual exclusive OR gives you 1, okay, whenever they are the same, and gives 0 if they are different, okay? So that's why 0, 0 give me 1, 0, 1 give me 0, 1, 0 gives me 0, 1, 1 gives me 1. So when we did this one, let's see here, 0, 1, 0, 1, I'm sorry, exclusive OR with 1, 1, 0, 0. This is 3. Okay, 1, 1 similar, get 0. Different, I'll get 1. The opposite, sorry. Similar, give me 0. This is exclusive NOR. Okay. 1, 1 gives me 0. 0, 1 gives me 1. 1, 0 gives me 1. And this will give me 0. Then I'll change it back to become 6. So this is exclusive OR. Okay. I'll stop here and I'll share it with you. We'll continue next lecture, inshallah. If you have any questions, I don't want to fill you with information now. I'll stop recording.